Welcome to this step-by-step visual demo of our submission, the Sherlock User Investigator for the Azure Sentinel Hackathon. At the moment, Sentinel does not provide a convenient way for an analyst to hunt or to do an incident investigation, besides using the general alert overview provided in the investigation panel within an incident. This limits the utility and strength in having multiple security data sources when they cannot be visualized together with ease for an analyst to interpret. This project was developed completely out of necessity, as they say necessity is the mother of invention. The potentials of Sentinel are great, however certain key characteristics are required to make a CM truly useful. So what is the Sherlock User Investigator? The key to good incident response, reactive and proactive detection is based on an analyst's ability to analyze key data points and being able to pivot around them. We brought together the power of Sentinel workbooks and KQL hunting queries to create a view that supports this. So the Sherlock User Investigator is a practical workbook that pivots an investigation around a user. It displays user-related alerts and activity from a range of data sources. These can be Microsoft or non-Microsoft. It gives critical incident context to the analyst, and Sentinel does not have a built-in feature that provides this capability. It focuses on giving key situational awareness and linking to supported security controls that cuts down the time and brings an investigation into one place. Here is an overview of the top section of the workbook. We attempt to leverage the strength of workbook features and applied to the strength of the KQL hunting queries. Important aspects such as converting data into images for fast and easy interpretation, searchable data relevant to the context, situational awareness of the user versus the organization were considered. Various features are integrated, such as the maps, tiles, graphs, etc. This is the middle section of the workbook. As you can see, a lot of data is easily summarized into a single page using various features. This is the bottom section of the workbook. We will go over these different panels and highlight the purpose and function of each integration. Starting from the top, key elements that set the stage for the workbook are the time frame and the user in question, with the user being our primal pivot point. This sets the scope and focus of the investigation. There are normally three main pivot points for an analyst, which are the user, the machine, and the IP. However, for the scope of the submission, we focused on the user pivot only, and host machine and IP will be made part of our future work. On the right of the workbook filters, there is a list of links. This feature focuses on the ability to connect the workbook view to its supporting controls when undertaking an investigation. This helps guide an analyst on where to go for deep dives in various parts of the Microsoft suite. There are different strengths in the Microsoft suite, but the various tools that support investigative work are not linked to each other in a way that is realized easily or intuitively for an analyst without having had extensive training on the entire suite. The playbook link mentioned there is more a proof of concept of an ideal scenario where certain playbooks can be initiated from a workbook. At the moment, it just loads the resource page. Okay, so the first data feature, which, like the rest to follow, uses queries that only pulls data related to the specific user, is from a syslog data source. It is an overview of proxy activity, and it makes use of hidden panels. The full category is shown in the slide, but in a practical application, we used certain categories that we considered were interesting. So in the above example, we can see a user was trying to access hacking materials. For an analyst, this provides immediate and direct overview into concerning activity by a user from the proxy. So if you were actually in the workbook, you could only see A, panel A, but when you click any tile within A, it would reveal a hidden panel, which is B, and that displays the data for that tile so that an analyst can see and read more detail. In this slide, we see the workbook where the backend query was written to limit it to only interesting categories. As you can see, it's less cluttered and more useful to weed out concerning user actions. In the top right, you can reset the selection, which hides the detail panel again from view. Moving on to the next panel. Azure AD is the core spine for user data. With this, an analyst is immediately able to determine the anomaly of a situation based on the account's context. For example, the department where it is occurring and the ability to contact the user directly for confirmation of an activity that just occurred. This data should be easily accessible when hunting or when investigating, so you can piece various security control data sources together. An example of this, but we're talking about it from the KQL query perspective, is that certain data sources would just have, for example, the email address, and for other data sources they would actually have just the username. So you have to tie these in together, and you would use that using AAD data. For this panel, a playbook was used to load in the AAD data, initially downloaded as a CSV, and then stored in a custom table within Log Analytics that could then be queried here in this panel. Moving on to the next feature. When investigating the incidents you see in Sentinel, for example, so you would possibly have an incident where there were multiple alerts that came from different data sources. The details, however, are brief and to the point. If you want to look at the alert in more depth, you'd have to fumble around to find that same incident and where it was triggered from in the originating security control. Why? This is because Sentinel has its own incident IDs and does not, for example, hold the data in a clear format to show that the incident IDs from each specific security control. The missing linkage is frustrating and time-consuming when investigating. If I see an incident for user Bob in Sentinel, I want to be able to get to the detailed console reporting it within a single click. This is the focus of this console. It has immediate actionable information and linking to support deep investigation. As an example, Windows Defender ATP provides deep analysis and automated investigations. If I am linked directly to the incident within Windows Defender ATP, I can then execute an automated investigation while I carry on my hunt. So by pulling in the specific URLs within the data that lead to that incident and making them clickable, this allows an analyst to immediately access and do deep dive investigations without getting confused. We were talking about actionable information. Here you see, if you click the alert itself, it pulls up a side panel which gives details that are of immediate use. One of the major examples here are the remediation steps. So remediation steps can be seen, which are pulled from relevant security controls. For example, Windows Defender actually allows you to pull this kind of information, and therefore it will be able to be actioned quickly. An analyst can delegate some steps to a colleague and go about their hunting in parallel. The panel also contains SIDs, the user's SID and the Azure's AD, and you can use these various IDs to, for example, link to other security controls. Clicking the username in the left would link you to the AAD user profile, and you can get full user details from there. For example, group memberships to determine the scope within Azure, and also in cases of a compromise, you can actually trigger a password reset. Visualizations are important tools to help an analyst assess and make decisions in small time frames. The timelines helps highlight connections between alerting from different sources. As different alerting sources trigger for different layers, one can trace where an attack started and what picked it up. Maps and patterns are always great for situational awareness. This map shows where a user logs in from, also noting the method, for example, browser or mobile. Outliers will stick out like a sore thumb and provide the analyst with a clue on how, like for example, an account was compromised. Example, an outlier from China. So just after the maps and the panel below, just after that specific section, the same data is actually shown in a grid. The anomalies seen in the map and the line graph can therefore be retrieved by the search function within the grid data and give the analyst immediate and timely information. The exact location details are linked by clicking on the city, and color coding for the client app helps you see a vertical pattern and pick out any anomalies from the grid view. Office activity is supporting data for an investigation. This aids the analyst in determining what exactly has been done in the environment within a specific suspicious activity time frame. Example, in the case of an exfiltration or insider threat activity, this is very useful information when trying to piece together the actions of the actor. There is no dedicated external console to look this up. Microsoft Cloud App Security highlights certain Office activities in the user profile, but it is not as detailed. You can retrieve this data using the O365 data connector in Sentinel, which provides that seamless integration. It is an excellent resource to support an investigation, even though it does not contain alert data. There is, however, currently no data connector for the O365 security and compliance alerts in Sentinel. These refers to alerts that detect the phishing, malware in emails, suspicious Outlook behaviors, for example, mass forwarding, etc. The data was pulled in using the API and a playbook. So not just standard sources and approaches were integrated, for example, syslog, but also we used the REST API. And finally, the graph here shows a relation between various characteristics within the proxy events to determine patterns that can help an analyst track a root cause, especially in the cases of multi-stage attacks. The relations between the bubbles are weighted by count. This helps to assist and add context in terms of traffic. All of the panels that were mentioned and discussed were all related to a specific user that we filtered on, and helps gives an analyst a full overview on the activity, the alerting activity, and the investigations that can be carried out, and all the avenues related to that specific user account within one workbook.